Hi guys, I believe that now you have learned something about the RF circuit with our previous 2G RF circuit course. So our course today is going to be about iPhone 6, 3G and 4G RF circuit. Also, to help you understand the RF circuit from all angles, we will explain you detailedly how the PRX circuit and the DRX circuit of the RF circuit work. First, let's take a look at the main component on the 3G and 4G RF circuit. LoRa antenna, LoRa cellular antenna connector. It is responsible for receiving and transmitting of the RF signals. UAT-SPLT, subcellular antenna connector. It receives and transmits RF signals of the DRX part. UASN-RF, antenna switch module IC. It controls the in and out switch process of reception and transmit signals. UMBPAD, mid-band power amplifier IC. It is responsible for power amplifier of mid-band signals. UWF-RF, sub-RF processor. For signals received of band 1, band 3, band 4, and band 25. UWF-RF converts them into IQ signals and then transmits these signals to baseband CPU for further processing. UWTR-RF, RF processor. It receives and transmits signals of different bands. Reception signals to be processed by UWF-RF are not included. UWTR-RF converts transmit signals from baseband IQ signals into RF signals and then sends them out. It also restores RF signals into IQ signals and then transmits IQ signals to baseband CPU for further processing. UHBS-RF, high-band antenna switch module IC. It controls the in and out and switch process of high-band reception and transmit signals. UHBPAD, high-band power amplifier IC. It is responsible for power amplifier of high-band signals. Now let's find out how iPhone 6, 3G and 4G RF circuit really works. First thing we need to know is bands of the network, compatible with phones nowadays and their corresponding carriers. As you can see from the chart, signal bands for phones are diversified and vary with countries and carriers. So when dealing with the RF circuit, we need to confirm the signal bands first. Next, let's take signals of band 1, 3G band, and band 41A, 4G band, as an example to show you how iPhone 6, 3G and 4G RF circuit works. Also, there are two sets of reception circuit for the RF circuit to ensure the stability of signals received. One is PRX and the other one is DRX. Normally, to ensure the accuracy of reception signals. Signals received by DRX will be supplementary signals for PRX. The TX process of band 1 signals is as follows. First, baseband CPU outputs 4 rails of IQ signals to the RF processor. The RF processor modulates these IQ signals and converts them into transmit signals of band 1. These signals are then transmitted to UMBPAD after the power amplifier process. These RF signals are transmitted to UASN-RF and then LoRa antenna, which will send these signals out afterwards. The PRX process of band 1 signals is as follows. LoRa antenna transmits signals received to UASN-RF. UASN-RF selects signals of band 1 from signals received and then transmits them to UMBPAD. After the power amplifier process, signals of band 1 are transmitted to the sub-RF processor. The sub-RF processor demodulates signals of band 1 into baseband IQ signals to be processed by the baseband CPU. The DRX process of band 1 signals is as follows. Sub-antenna transmits signals received to UASN-RF. UASN-RF selects DRX signals from signals received and transmits them to UDSN-RF. UDSN RF selects DRX signals of band 1 from signals received, and then transmits them to the sub-RF processor. The sub-RF processor restores them into baseband IQ signals, and then transmits them to baseband CPU for further processing. Next, let's move to the receiving and transmitting process of band 41A signals. The same process like band 1 signals mentioned above. The TX process of band 41A signals is as follows. Baseband CPU to the RF processor, to UHB PAD. Baseband 40A and 41A signal transmit filter, to UHBS RF, UASN RF, to lower antenna. The PRX process of band 41A signals is as follows. Lower antenna to UASN RF, to UHBS RF, to band 41A and 41A signal reception filter, to the RF processor, to baseband CPU. The DRX process of band 41A signals is as follows. Sub-antenna to UASN RF, to UDSN RF, to band 41B and 41A DR filter, to the RF processor, to baseband CPU. Now let's move to diagnose and maintenance of the 3G and 4G RF circuit. If the phone features searching issue, weak signals, internet connection failure, or unstable signals, first, replace with SIM cards of different carriers and test, so as to confirm whether the fault is caused by networks of the carrier. Then, update software of the phone to rule out software problems. When testing with SIM cards of different carriers, if the signal failure appears only with some carriers or some networks, 2G, 3G, and 4G, then reception and transmit circuits of some band are abnormal. We can work some corresponding circuits of these bands with the help of a diagram. The maintenance process of some specific bands will be introduced later. When testing with SIM cards of different carriers, if the signal failure appears with all carriers and networks, 2G, 3G, and 4G, then we need to confirm whether the fault is related to the baseband circuit, the RF circuit of the SIM card. We need to check info under the About category, so as to confirm whether the phone features blank ICC ID and IMEI number. Meantime, spread out the dialer board and enter #06#. Check if there is IMEI number displayed on the screen. If either or both two methods failed to access the IMEI number, then the fault is related to baseband CPU or relevant components on the RFFE bus, and we need to check components on the RFFE bus first. If the IMEI number can be accessed with both two methods and then the fault is related to the RF circuit, we can select a network manually and check whether there are carrier signals. If yes, then the reception circuit is in normal condition, and the fault is related to the transmitting circuit. If no, then the fault might be related to the reception circuit or the transmitting circuit. And we need to check both reception circuit and transmitting circuit. Once we have confirmed that the fault is related to the RF circuit, if signals of all boards are abnormal, if signals of all bands are abnormal, then the fault is related to the common part of all bands. For example, UASN RF, UWTR RF, or baseband CPU. If signals of some band are abnormal, then we can select an abnormal band and check. Now, let's take band 41A as an example to show you. Diagnose and maintenance of the reception and transmitting circuit. First, run cosmetics inspection of the logic board and check whether band 41A relevant area is normal. Then, connect an external antenna with the following node, one by one. Reception passage. 1. Lower antenna. 2. C5128RF. 3. R4608RF. 4. L4709RF. 5. C4720RF. Transmit passage 1. C4502RF. 2. L4501RF. 3. L4507RF. 4. C4721RF. 5. C5128RF. If the signal stress is obviously improved, with one specific node connected, then the fault position is located between the specific node and the node located in front of it, and we need to check components between the two nodes. If the working condition of these components is normal, then we need to replace the corresponding component. If all nodes fail, then we need to check working condition of the RF processor. If nothing goes wrong, replace the RF processor. If the problem still remains unresolved, check baseband CPU relevant circuit. Common fault components of the 3G and 4G RF circuit. Malfunction of UWTR RF will result in issues like searching issue, no service, or unstable signal of the phone. Malfunction of UASN RF will result in issues like searching issue, no service, or unstable signal of the phone. Malfunction of UHBPAD will result in issues like no 4G signal, unstable 4G signal of the phone. Malfunction of UMBPAD will result in issues like no midband signal, unstable midband signals of the phone. Malfunction of UQPOET will result in issues like searching issue, no service, or unstable signal of the phone. Malfunction of UWFR-RF will result in issues like no signal of some bands, no service, or unstable signal of the phone. And this is our detailed explanation how iPhone 6, 3G and 4G RF circuit works. Feel free to visit our official website www.rivatechnology.com. See you next course.